Behind every simple lipstick lies a world of chemistry, engineering, and precision manufacturing you've never seen before.
For thousands of years, humans have colored their lips.
In ancient civilizations, lip color came from the earth itself. Crushed minerals, red ochres, and plant.
But the true transformation began during the Industrial Age, when chemistry, mass production, and global trade developed.
By the mid-1900s, the twist-up lipstick tube became standard. This was not just packaging design.
Behind every lipstick shade now lies chemistry. Oils determine glide, waxes control structure, pigments define opacity and tone.
Today, lipstick is a multi-billion-dollar global industry. Each shade you see in stores is the final.
And in this documentary, we step behind the scenes, inside real industrial manufacturing facilities, to discover how lipstick is truly made.
Before lipstick ever reaches the factory, its ingredients begin a global journey. Waxes from tropical plants.
Oils form the heart of lipstick. Castor oil, one of the most common, gives the product its smooth glide. These oils act as emollients.
Waxes give lipstick its structure. Beeswax adds flexibility. Candelilla wax increases firmness.
The color in lipstick comes from finely milled pigments. Iron oxides create natural reds and browns.
Some lipsticks shimmer. This effect comes from mica, a naturally occurring mineral that reflects light in.
Every raw ingredient is tested before use. Manufacturers verify identity, purity, and absence of contaminants like heavy metals or microbes.
In factories, ingredients are stored under controlled conditions. Temperature, humidity, and labeling systems protect.
Once all raw materials pass inspection, they move to the blending stage, where waxes, oils, and pigments unite.
Even though lipstick looks like a solid stick, chemically it is a complex mixture.
Every wax has its own melting point. Beeswax melts around body-warm temperatures. Carnauba wax melts much higher.
Rheology is the science of how materials flow. Lipstick is designed to deform under pressure, meaning it spreads easily but regains structure afterward.
Pigments don't dissolve, they disperse. To prevent streaks or patches, the particles must be evenly distributed throughout the
Oils can oxidize over time, slowly reacting with air and light. To protect.
The formula must also be compatible with human skin. Cosmetic chemists design lipstick to be non-irritating.
The final finish, shiny or matte, is determined by formulation. Higher oil content and reflective particles create gloss.
With the chemistry understood, the next stage begins. Oils, waxes, and pigments are
Before color ever enters the lipstick base, it must be prepared with scientific precision. Cosmetic pigments arrive as ultra-fine powders.
The powders are passed through precision sieves. This removes large particles and breaks small clumps apart.
Dry pigment doesn't simply dissolve, so chemists blend it with oil first, allowing each pigment particle to become fully wet.
This wet pigment paste is then refined in a triple roll mill, one of the most important machines in lipstick production.
The quality of dispersion is measured using standardized tests. If particles are too large, the lipstick will feel.
Color accuracy matters. Spectrometers compare each batch to a master reference shade, detecting even tiny.
Let's liqueur thing. Once the color passes inspection, it is sealed and labeled for blending. Every container carries batch numbers. With pigments now fully prepared, the next step begins. Precise amounts of color are added to the melted wax and oil base.
This is the heart of lipstick manufacturing, the mixing hall. Here, waxes, oils, and pigments.
Production begins with the waxes. Solid wax pellets are heated inside jacketed kettles, vessels surrounded by temperature-controlled hot water or oil.
Once the wax is fully liquid, cosmetic oils are added. These oils soften the structure, improve glide, and help disperse pigments later.
Next, the prepared pigment concentrate is added.
Because pigments were pre-milled, they disperse smoothly through the molten mixture.
As the mixture blends, small air bubbles can become trapped. If left inside, they create pinholes or weak.
Technicians continuously sample the mixture. They check viscosity, the flow group.
When the base is approved, the molten lipstick is transferred through heated lines to the molding department.
Once the molten lipstick is blended, it arrives here, the molding line. This is where the liquid formulation becomes a solid product.
Lipstick molds are engineered from highly polished metal. The inner cavity must be perfectly smooth. Any microscopic scratch would imprint onto the final product.
The molten lipstick is transported through heated pipelines to prevent early solidification. Temperature stability is critical.
Filling begins. Each cavity receives a measured volume of product. The filling rate is controlled to avoid turbulence or trapped air.
Next, the molds enter a controlled cooling tunnel. As the lipstick cools, the waxes recrystallize, returning from... When the structure fully sets, the molds open. Precision robotics lift the lipstick bullet cleanly from the cavity.
Any small surface marks are removed through trimming or gentle polishing. This final refinement step ensures a flawless finish.
Once the lipstick bullets are molded and perfected, they enter the assembly line. This is where engineering meets presentations.
At the heart of the tube is a threaded lift mechanism. When the user twists the base, the spiral track raises and
Robotic arms place each lipstick bullet into the inner cup of the mechanism. The bullet is pressed into position so it bonds securely.
In many factories, the base of the lipstick is gently warmed to create a secure bond.
The mechanical core is then enclosed in its finished outer shell. These casings are designed both for strength and aesthetic.
Finally, the cap is attached. It must click firmly into place, protecting the product from drying, dust, or accidental twisting.
Each unit receives a batch code, a fingerprint for manufacturing. This allows every lipstick to be traced back to the...
Before leaving the factory, every lipstick undergoes visual inspection, alignment.
Before a lipstick ever reaches the store shelf, it must pass rigorous testing. Quality control laboratories verify.
The first test is visual inspection. Technicians look for surface imperfections, tiny cracks, air pockets.
Lipstick may look delicate, but it must survive real-world use. Mechanical testers apply downward force to measure break strength.
Next comes heat stability testing.
Samples are tested for microbial contamination. Although lipstick contains waxes and oils that resist bacterial...
Color accuracy is measured using spectrophotometry. Instruments detect light reflection across the visible spectrum.
Texture testing evaluates glide, friction, and creaminess. The lipstick must move smoothly across the lips, neither dragging nor slipping excessively.
Only after passing every test is the batch approved for release. Quality control is not the final step. It is the guardian of trust.
First comes primary packaging. Robotic pick-and-place systems position each lipstick into its retail carton.
Laser systems apply batch numbers and manufacturing codes. If a quality issue is ever detected, these codes allow rapid tracing and recall.
Every unit passes through weigh-check machines and seal verification sensors. If a box is too light...
Next, units are grouped into protective shipping cartons. These cartons shield the product during transportation, absorbing vibration, compression, and thermal changes.
Robotic palletizers stack cartons with geometric precision. Each pallet receives a digital ID.
Finally, distribution begins. Trucks, cargo ships, and aircraft deliver.
The journey that began with raw oils, waxes, and pigments now meets its purpose. Every lipstick on...
The twist-up mechanism you use each day is a miniature machine. Internal threads convert rotational motion into...
When lipstick touches the lips, body heat softens the wax structure. Oils spread first, carrying.
Comfort, staying power, and finish all depend on formulation design. Some lipsticks emphasize moisture and sheen.
The future of lipstick is evolving. Researchers are developing plant-derived waxes, lighter natural oils.
Packaging engineering is also transforming. Refillable casings and recyclable materials reduce environmental.